Hi everybody, so I'm going to do a few trig identities just to show some steps and to kind of give you some hints as to how to think about this. The first one I have is 1 minus sine v over cosine v plus I have cosine v over 1 minus sine v. And we want to show that that's equal to 2 secant of v. So I notice I have different denominators here. So that is going to be my strategy of how to start. So I'm going to use the left side. I'm going to find a common denominator. So I'll show you the long way. So the long way would be, the common denominator would be cosine v times 1 minus sine v. So I'm going to multiply the first one by 1 minus sine v over 1 minus sine v. Remember that's equal to 1. So I haven't changed anything. I have 1 minus sine v over cosine v. And then the other one, the second one, I need to multiply top and bottom by cosine v to get the common denominator. And again, remember cosine v over cosine v is 1, so let's write what we have. So now we're ready to do some expansion. So first this 1 minus sine v times 1 minus sine v, this will be 1 minus 2 sine of v plus sine v squared, or sine squared v. So we just squared 1 minus sine. Remember, when I square a binomial, I get a trinomial. The other side, I have cosine v times cosine v, that's cosine squared v. And the bottom, I have this big denominator. So let's look at what we have. I have 1 minus 2 sine v, I have sine squared v, I have cosine squared v. Well, we know sine squared plus cosine squared is equal to 1. So why don't I make that 1 minus 2 sine v plus 1, and then leave the denominator 1 minus sine v cosine v. Well, 1 and 1 is 2, so now I have 2 minus 2 sine v over 1 minus sine v cosine v. This 2 is in common, so let's take that out. I have 1 minus sine v over 1 minus sine v cosine v. Really good. 1 minus sine v, 1 minus sine v. So we're at that point where that can cancel. I have 2 over cosine v. Well, 2 over cosine, that's just secant, so I have 2 secant v. So we've started on the left, and we ended up what we had on the right. So that means that we showed that the identity is true. This time I have 1 minus sine theta over 1 plus sine theta is equal to secant theta minus tangent theta, and that's squared. I'm going to do this one a little differently because when you look at the two sides, you're looking for which one looks harder, and I think this one looks harder, the secant theta minus tan theta squared. So I'm going to start there. I'm going to square secant theta minus tangent theta. So secant squared theta minus 2 secant theta tangent theta plus tangent squared theta. From here, I'm going to think, well, I know eventually I want to be in sine and cosine, so let's go ahead and change things around. So secant, I'm going to have 1 over cosine squared theta minus, I'm just going to leave the 2 on top, and I know that secant is 1 over cosine, so I'm going to write 2 over 1 just so the 2 is out. I have cosine theta for secant. Tangent is sine theta over cosine theta. And then tangent squared is sine squared theta over cosine squared theta. So something really nice happened here is the first term has cosine squared, the second term is cosine squared, the last one is cosine squared. So I have a common denominator already. So let's look at the numerator. I have 1 minus 2 sine theta plus sine squared theta. And that's all over cosine squared. The end of the problem wants to be in sine, so let's take this cosine and say, well, I can change cosine squared into 1 minus sine squared. So I have 1 minus 2 sine theta plus sine squared over 1 minus sine squared. Now everything's in sine, so that's part 1 of getting this to be what we want it to be. Then I think, well, I could factor it. So 1 minus 2 sine theta plus sine squared theta, that's just really 1 minus sine theta times 1 minus sine theta. And then on the bottom, I have a difference of squares, so I have 1 minus sine theta times 1 plus sine of theta. And then I look that the 1 minus sine thetas cancel. So what do I end up with? 1 minus sine theta over 1 plus sine of theta, which, if we go back, is what we wanted. So this time I started with the right and I ended up on the left. So it doesn't matter which side you start on, it just matters that you get the answer. So let's try one more. This one says cotan of theta over 1 minus tangent of theta plus tan theta over 1 minus cotangent of theta is equal to 1 plus tangent of theta plus cotangent of theta. All right, so really big problem, and what I think to do is like, what if I put everything in terms of sine and cosine, just as a place to start. So cotangent would be cosine of theta over sine of theta, and then 1 minus tangent, I have 1 minus sine of theta over cosine of theta, plus tangent again, so I have sine of theta over cosine of theta, and I have 1 minus, this now is cosine of theta over sine of theta. So now everything is written in terms of sine and cosine. I don't have anything on the right, but I don't want anything on the right. I want to end up proving what's on the right. So now as I want to go a little farther, I have these fractions within a fraction, and I really don't want to have that. So I'm going to look at the denominators and see what I can do with them. So let's leave the top, cosine theta over sine theta. And instead of having 1 minus sine theta over cosine theta, I'm going to change the 1 into cosine theta over cosine theta minus sine over cosine. Still a plus. Then the second expression, sine theta over cosine theta. And I'm going to do the same thing here where I say 1, I'm going to make that sine theta over sine theta minus cosine over sine. So the idea is we want to be able to put these things together so we can flip our fractions. Cosine theta, sine theta, I just drag that along. But this now, the cosine theta over cosine theta minus sine over cosine, I can put cosine minus sine together. So cosine theta minus sine theta over cosine theta, that's the denominator, plus, kind of similar on this side, I have sine theta over cosine theta. And again, I'm putting these two together because they both have a denominator of sine now. So I have sine theta minus cosine theta over sine theta. Now I can flip these. So I'm going to keep the cosine theta over sine theta, but then I'm flipping this over. So I have cosine theta over cosine theta minus sine theta. Plus, I have sine over cosine. And again, I'm flipping. I have sine minus cosine. Cosine times cosine, now I have cosine squared theta over sine theta times cosine theta minus sine theta plus sine, so I have sine squared over cosine of sine theta minus cosine theta. Once again, I need a common denominator so I can move forward a little bit. So I'm looking at what each one has, what each one's missing, how close are they. So cosine minus sine and sine minus cosine. If you look at sine theta minus cosine theta, if I factor out a -1, it becomes negative sine theta plus cosine theta, which would be -1. I can make that cosine theta minus sine theta. So I wanted to reverse the order of the sine minus cosine to match the first term. If I do that, if I change this, this is cosine squared over sine theta. Then I have cosine theta minus sine theta plus, here's sine squared, still have cosine theta. Now I have the -1 and I can write it as cosine theta minus sine theta. You could move this negative up to the top or in between, but somehow we want to make that minus in between. The first term, I have sine on the bottom, but I really need it to be sine cosine, so I'm going to multiply top and bottom by cosine. So what that does is it makes it cosine cubed. And then on this side, I need a sine because I don't have the one over here, so I'm going to put a sine, so this will be sine cubed. And this negative, I'm going to move it here. And then I have sine theta, cosine theta, and then cosine theta minus sine theta. Before we had the difference of squares, this time I have the difference of cubes. So this becomes cosine of theta minus sine of theta, and then I get cosine squared theta, then I have plus sine theta cosine theta, and then plus sine squared theta, all over sine theta, cosine theta, cosine theta, minus sine theta. Now the cosine minus sine cancels the cosine minus sine. I have cosine squared theta plus sine theta cosine theta plus sine squared theta over sine theta cosine theta. So now we're going to break this up. I'm going to put cosine squared theta over sine theta cosine theta. I have sine theta cosine theta over sine theta cosine theta. And then I have sine squared theta over sine theta cosine theta. A little bit of reducing. One cosine cancels one cosine. So I still have a cosine theta left. So I end up with cosine theta over sine theta. This sine cosine over sine cosine is 1. One of the sines cancels in the last term. So I have sine theta over cosine theta. So cosine over sine, that's cotangent of theta. Plus 1. Sine over cosine is tangent of theta. You go all the way back to what we were supposed to be doing. We were finding that this was 1 plus tangent plus cotangent, which is exactly what we did. So that's a super long one, like I know that. And you may have a different approach that you want to do. Like some of these, there are more than one way to do it, and that's perfectly okay. This is just the way that came to me to do it, so I show you what I thought. So I hope that's helpful. I know these take time. You can always go back and like watch this in a day or two, because I know you're not going to memorize it from watching it once. Try it again where you kind of just watch the video, see what you can do without me, play till you need to get a little help again, then pause again. That may help to get you used to these, because identities do take some time. They are a different kind of math. You're so used to solving equations, and here I'm not trying to solve. I just want to show things are identical.